So today we are going to talk about a very interesting topic in Spring AI, that is RAG. But before that, what is RAG? And to understand that, let's take an example. Let's imagine you have created a AI chatbot for your organization, and you are asking to your chatbot that what is the leave policy of my organization, and it replies you with full confidence but completely fake information. So what do you think? AI model is not capable to answer it, or whatever you have developed that is not correct? No, that is not the case. So the thing is, like, you are asking questions related to your company, but these LLM models are trained on public data. They don't know anything about your internal data, documents, PDF, nothing. It is replying but completely fake information. And that is what we call hallucination. And the cure of this problem is RAG. So RAG is nothing but a retrieval augmented generation. Now let's imagine AI as a very smart student, and it has access of billions of pages on the internet, textbook, repositories, Wikipedia, articles, whatever is publicly available on the internet. But whenever you ask questions related to your company data, which is not for public use, those are private data. In that case, it will hallucinate. It will give you the answers, but that answers may be correct or incorrect. Now let's imagine you have created a private library, and that library contains all the documents related to your company. And whatever private library you have created, you gave the access to AI student. So next time, whenever AI student is going for any final answer, first she will scan all the documents, read them carefully, and then only it will construct the final answer. So if you try to understand this in terms of RAG, so the private library where you stored all the data, so this library is nothing but a database or a vector database where you stored all the documents in form of chunks. And when the AI student is going inside that library and finding the relevant documents, similar documents, so that is nothing but a semantic search. And after that, picking up the relevant pages on the basis of that query, that is nothing but a retrieval process. And here the AI student is the actual model. And this whole process of searching the document, starting from the library and going through each and every shelf, finding the relevant document and retrieving the relevant document, all this process are commonly called as a RAG. Before jumping into the code, first we will understand the RAG architecture. So it has two separate architecture or two separate pipelines. First is your ingestion pipeline or ingestion jobs. So in ingestion pipeline, you load your company related data and store it in the database. And you will run this ingestion pipeline only once when you will load your application. And next is the query job or a query pipeline. And this query pipeline will execute every time a user is asking any question. So first we will understand the ingestion pipeline. The first thing is loading your document. So here you will load your company related document. It can be a PDF, text file, or any company manual. Whatever you want to upload, you can upload it. After loading the document, the next step is splitting those documents in form of chunks. Because whenever you upload PDFs, let's imagine you are uploading a PDF of 50 pages. So it is going to be a huge size document, and it will take a lot of memory. And whenever your models are going to use those PDF, you have to invest a lot of tokens for that. So it will cost you more. And after splitting the document, you will pass those chunks data to embedding models. So embedding models will convert those chunk data in numbers so that your models or machine can understand it in better way. And after converting all these text into numbers, you will store those details in vector database. So this is what we do in ingestion pipeline or in ingestion job. And it will run only once when you will start your application. After that, our next step is query pipeline or a query job. This will run every time whenever a user is asking any question. So earlier we took an example of that company policy, like what is the leave policy of your organization. So if user is asking that question, then that question will go to the embedding models. Using embedding models, we will convert those questions into numbers. And after that, we will try to find those questions related details in database, in vector database. And after finding the details in the database, the next step is prompt augmentation. So in prompt augmentation, it will inject those relevant document to the prompt, or it will add that context to the prompt. And after that, the final query will go to the LLM models for the actual response or more accurate response. So now LLM model understand your question. Now it is attached to your, now it has the details of your company, and it will generate the more accurate response for your query. So this is the query pipeline. Whenever user is asking any questions, all these query pipeline will execute. So now we will jump to the code part and we'll create a RAG application using a Spring AI. So the tech stack, so if I talk about the tech stack, then we are going to use a Spring Boot 3x Plus, then Spring AI, OpenAI, because for LLM models, we are going to connect with OpenAI. And it is going to be a Maven project, and JDK version which we are using in our project is 21. And since we are going to connect with a database, vector database, so for that we are using PG Vector. So we have created this initial project using Spring Initializer. And this is our RAG application. So if I go to the pom.xml, so you'll see that we are using Spring version 3.5.3, and Java version is 21. And we are using BOM model for Spring AI, and its version is 1.1.0, and we need few dependencies like Spring Boot Starter Web. Then since we are going to connect with the PG vector, so you need that dependency as well. And for LLM models, we are using OpenAI, so the OpenAI dependency is added. Since JDBC connectivity will be through PostgreSQL, so its dependency is added. Now it's time to add configurations for like, since you are going to connect with LLM models, then you have to add OpenAI configurations, and with that you have to add some additional configurations like you will be connecting with the database. So I will open application.properties file, and first three section is for OpenAI configuration. So you have to provide here OpenAPI key, and if you want to use any other models like Gemini, Claude, then you have to add its configuration. And we are using here a GPT-4o mini model, and since we are going to use embedding models in our RAG applications, so for that we are using this OpenAI text embedding models. After that we have to provide JDBC connectivity. So we have provided a URL, username, passwords. These things are common, and since we are going to connect with PG vectors, so you have to add this configuration here. This debug configuration is optional. If you want to add it, you can add it. And to install a PG vector in your database, there are two ways. One is you can so I am running a Docker container for PG vector, and for that you have to provide this command on your CLI. And after that, once you run the application, you would be able to connect with this database. So you can see that our application is running on 8080 port. And now the initial configuration is done. Now your database is up and running. And the next step is loading your company related document or private document which you want to pass to LLM models. So for that we'll use document ingestion, and using document ingestion we will load the private data which you want to pass it to LLM models. So for that we'll create a config class. So this will be your ingestion config class, which is going to load the private document which you want to pass it to vector database. So we have created this ingestion config, and inside this ingestion config we have an ingest method, and the first parameter is the vector store. So it will inject the bean of vector store. Then we have embedding model. Then we have an embedding model, and inside this method, the first line is like it will fetch the document from this location. Like it will look into the source main resources folder, and inside this you should have a docs folder, and inside docs manual txt should be there. if you want to define these to some other places, or if you want to upload, if you want to fetch it from some cloud based storage or somewhere, then you have to provide its configuration. So in my case, I am going to create a document file in this docs location. So I will go to the resources, and then I will create a directory for docs, and inside docs I will create a file manual.txt, and inside this manual.txt, whatever content I will provide, that will be stored in the database. Like initially I asked that what is the leave policy of my organization. So I am going to provide the same details to this manual.txt file. So I have pasted a leave policy of some organization, and so from the next time whenever I'll ask any questions related to leave policy, it should not go to the Google or any public data. It will fetch from this library or this document, and then it will generate the response. So now we'll store that txt file details in a text reader object, and this text reader will return object in form of documents. Next step will be split those document in form of chunks. So you for splitting the data, we are using a token text splitter class, and using that we will chunk the document, and we will store it into the list of document chunks. So after this step, this line will use embedding model, and using embedding model, it will convert those chunk data in form of numbers, and then it will store it into the database. So for embedding, we are using this model. You can see here Open API embedding options model. So using this line, you are providing that what type of embedding model you want to use. So here in step 3, it will embed and store your chunk data in vector store database. And now you're done. This is what we do in ingestion pipeline. So we have created a chat controller class, and using this class we'll get the query from the user, and we have created a chat client object through which we'll connect with the model. And in this chat get mapping method, we'll get the message from the user, and then we will pass that message to the user, and then it will return the response. So now our controller is ready. Now we are ready to accept messages or a query from a user, but still we but still model is not aware about the private data which is available in this manual.txt file. We have created our vector database. We have configured the document ingestion. Our document is stored in the database, but that connectivity is not there with the model. Your library is ready, your private library is ready, but still your AI student is not aware about that library. We'll do that connectivity later, but first we'll see, like, without that private library, how this AI student is behaving. So I have created a request in Postman. It's a get request, and in get request we are passing this request parameter message, and message will have what is our company leave policy. So if you see here, in code, it will directly go to the chat client, and using chat client we'll get the response. So it means a direct model. So we'll hit this request. Okay, so after hitting the request, you see that we are getting to provide you more accurate information about your company leave policy. I recommend checking your employee handbook or the company's HR resources. So I will say it's not hallucinating. It is giving you the proper response, because whatever you are asking, it's a private data. It's not available on the public internet. So now you will see the real magic of RAG. Using RAG, how it will connect to your company related data, and it will give you the response. So for that, we'll go back to the code again. For that, we have made some changes in our code, that we will use this vector store, and we will create the object or a bean of vector store here in this controller, And in the chat client, if you see that we are using advisors, and in advisors we are using this question answer advisors. So using that, it will do all the magic. It will go to the vector database. It will, get the details related to your query. It will find relevant details related to your query, and if there is any response, then it will return it in the final response. So here I'm getting some error on question answer advisor because I need to use a dependency for this class. So you have to define this dependency in pom.xml to use advisors in Spring AI. Okay, now we'll import this class. So now your private library is connected to the AI model. So we'll see one more time what is there in the manual txt. So you'll see that we have a few types of leave policy: annual leave, sick leave, casual leave. And so for the same query, we should get all these response in our query. If we are getting, means rack connectivity is working as expected. Okay, now I'll go back to the same request and let's hit this request. Now we got the response. So now it's saying our company leave policy includes several types of leave: annual leave, sick leave, casual leave, maternity leave, paternity leave, blah blah blah. Different types of leaves are there. So now it is fetching your document. So this is how RAG works. So I hope you are clear with the RAG architecture and how RAG works internally. If you have any doubts, please do comment. And if you like this video, please share this video with your friends. Subscribe my channel. See you in the next video. Till then, goodbye.